Welcome everyone. Do not leave. We are waiting for Mr. Lokesh to join. The session will start very soon. Lokesh, are you here?
Yes, I have joined.
Okay. Akhya, are you here? Akhya?
There's some echo on your side.
Just a second. Sumit, are you here? Sumit? Okay. Akhya, are you here now?
Yes, sir. Sorry for the disconnection.
No problem. We can start the session now. Mr. Lokesh is here.
Yes, sir. So, shall we start?
Yes, yes.
Good afternoon, everyone. It is with great pleasure that I extend a warm welcome to everyone who has joined us. On behalf of Alumni Cell of Government Engineering College Bharatpur, I extend a warm welcome to our principal, sir, Dr. Ravi Gupta, and a dedicated team of teachers. This session is organized by Alumni Cell of our college and coordinated by Mr. Ankit Panch, Assistant Professor in the Department of Computer Science and Engineering. This session provides a chance for our current students to glean insights and wisdom from those who have walked the path they are now embarking on. Before proceeding further, I would like to introduce myself. I am Akhya Singh, pre-final year student of Computer Science and Engineering. So, as we embark on the journey of reconnection and reminiscence, I would like to introduce our today's guest, Mr. Lokesh Sharma. Mr. Sharma is from 2012 batch with a specialization in computer science. With over 7 years of experience, Mr. Sharma is a seasoned cybersecurity professional, currently excelling as a lead cybersecurity specialist at Grab. Mr. Sharma has also received recognition from tech giants such as Google, Meta, and Microsoft for his contribution to the cybersecurity community. Mr. Sharma, thank you for joining us. Now you may take over the session ahead.
Thank you, everyone, for inviting me here. So, for the session today, I'll be talking about cybersecurity. I'll be giving a brief overview around what cybersecurity is, how the career opportunities look like in this cybersecurity space, what are the different career paths and the verticals of cybersecurity, what are the different factors that are considered when you are working in this cybersecurity, what are a different type of security work that you're going to do. I'll also want to have this as an interactive session. Assume majority of the people who have joined here will be from computer science engineering department or have some either the network related background understanding or on the application front any programming experience or something. So it'll be great if we can have an interactive conversation, because I want to have a discussion wherein we can talk about a web application, and I will lead you guys towards a discussion wherein you can talk about how the application works, how do you design an application, how do you write the code, how do you implement authentication and different things. And I can walk you towards how the security is embedded into each of those steps. How does security come into play when you are writing the authentication? How does security come into play when your application is interacting with your database and all of those, right? So those kind of discussion I want to have. Let me just share my screen. Do I require any special permission to share the screen?
No, I don't think so. You can just share it. Not able to?
Just a second, let me try again. think, yeah. Is it visible now?
Yes, yes.
Okay. So, as I mentioned, the topic for today is an overview of the cybersecurity landscape and a brief introduction about me. I've already been introduced, but just to mention, so I have been working majorly in the application security, and recently I have moved to work towards cloud security and network security. And within cybersecurity, I will introduce it later, but within cybersecurity, there are many different paths in which you can work. There are paths related to application security, network security. Cloud computing has been like a major vertical right now. We have AWS, Azure, GCP. So there are security verticals for cloud security. There are verticals for compliance, governance, regulations, data security, information security. There are like a lot more different verticals within cybersecurity that you can work on. My major work has been on application security and cloud security. And recently I have been focusing on network security, security automation, and these type of things. So what we will be discussing on here. So first thing that we will be discussing on is introduction. I'll just give you a brief on what is cybersecurity. Why would you want to work in cybersecurity? What you're going out of working in cybersecurity? Why is it an interesting or inspirational career path? We'll be talking about the different paths that are there in cybersecurity. Then we'll have a short discussion. I want this to be an interactive discussion. We can have a discussion about a particular topic related to cybersecurity. And next, I'll be sharing some learning sources that you can use to get into the cybersecurity career. And then I'll be open for some Q&A. So what is cybersecurity? So the definition is there, but in general, when you think of cybersecurity, what comes to your mind? Like, anyone wants to answer that? Anyone? Okay, so in general, when you think of security, right? So first thing that comes to mind is fraud. So that is the first thing that you hear, right? So someone's money is lost from their bank account. Someone got messages in Facebook from their friend, but their friend did not actually message them. Someone's account is taken over by an attacker or a hacker. So these are the things that you generally think of. But when you try to categorize it into cybersecurity, right? What does cybersecurity actually mean? So cybersecurity basically works in three different sections. One is confidentiality, second is integrity, and third is availability. What does these three mean? Whenever you have a digital application, internet-based application, any hardware, any mobile application, anything, right? Anything that is connected to the internet. Whenever you have such a system, it has three main components. One is the confidentiality, but confidentiality of what? Confidentiality of your data, your information. So let's say Google Meet right now. So we are on this Google Meet call. And within this call, we all can see who has joined this call. But should anyone else be able to see this? Someone who is not invited to this call, right? So that is the confidentiality. Second is integrity. What does integrity mean? So integrity means right now I'm speaking and on the screen you can see that it is showing my name, Lokesh Sharma. But what if I change my name? What if I change my name to Government Engineering College? Then would I become Government Engineering College or would I be representing Government Engineering College? No. So there has to be a layer of integrity implemented on all of the data that you put into your digital applications. Any application, any sort of application. Let's say Facebook, you're sending message to someone. But when the receiver receives that message, he should be able to see that it is coming from this person. The name should not be modifiable, right? That is integrity. That the system provides you a layer of integrity that this message is what it says it is. This message is coming from the person who says he's sending it, right? So that is a layer of integrity. And the third part is availability. What does availability mean? What happens if suddenly Google goes down and this call is dropped? What happens suddenly tomorrow your mobile applications stop working? What happens suddenly if you cannot send any WhatsApp messages tomorrow, right? It can happen for a lot more reasons, right? It can happen for some operational reason. Let's say some developer just deployed a buggy code, right? Or it can happen that an attacker started to do an attack on WhatsApp and it disrupted their network. Let's say someone sends out a lot of HTTP request, which is flooding the WhatsApp network, and now no one can actually access the WhatsApp domain. Right? So there can be a lot of reasons, but the target for cybersecurity is to ensure that sufficient controls are in place, that availability, integrity, and confidentiality of your applications are managed. Right? So that is what cybersecurity is. Now, how to achieve that? That is a whole lot to discuss about, right? So we can go into the depths, and like I can write like hundreds of pages, and still it will not be sufficient to explain how the cybersecurity can work in these sections, right? But to give a brief, right, how does cybersecurity implement these controls, right? So there are layers of controls, right? So I was mentioning about, we will talk about how security can be embedded into an application. But if you look at on a holistic point of view, right, whenever there is an entity, it can be an application, it can be a network, it can be your servers, it can be your cloud infra, whatever, right? There are layers of steps that comes into picture whenever you are accessing or doing any task. So let's say, just take an example of this, right? Google Meet, right? Easier to understand. What did you do? You first needed to have an access to a link. Second, you click on the link, the domain is resolved, you get an IP of the Google Meet domain, and then a request is sent there, and then you connect to that application with an HTTP request. Then on this link, there was no authentication, but on Google Meet, you can have an authentication. So you have to either provide a code, or someone who is already there in the call needs to accept your request to join this call, right? So that adds a layer of authentication. And then once you are in the call, you need to be like having a seamless visibility on what is happening in the call. You should be able to speak properly and all of that, right? So there are different stops involved. But security attacks can also happen on each of the steps, right? Let's say the link is leaked, or let's say this link has how many, like 9 characters. How much time do you think it will take for 9 characters to be guessed, right? If those characters are guessed, someone has access to the link. Now, if they have access to the link, they'll visit it, and they will also be able to join this Zoom meet, Google Meets meeting, right? How do you prevent that? That part comes with the security. Now, security, when you think of it, right, it doesn't necessarily mean implementing a control or implementing a guardrail, right? It's not always about creating fences. Sometimes it's just about changing the way you do things, right? So instead of having a 9-character code, you could have a GUID. How many people here know about GUID? You can raise hands if you don't want to speak, or emojis. But whoever is studying in computer science engineering, at least should know about GUIDs. So GUID, you can think of it as a 32-character, 36-character alphanumeric string, and it is uniquely generated based on your system fingerprints, right? So every time you generate a GUID, it will be completely unique, and there is a less than a trillion chance that you'll get a duplicate. So once you generate a 36-character unique GUID, there will not be a duplicate of it, at least. Let's say this meeting is only lasting for, let's say 1 hour. Now, after 3 or 4 hours, even if someone is able, though it will not be possible, but even if someone is able to guess it, it will take at least them hundreds of years to guess that. But this meeting ends in 1 hour, right? So that reduces your entire security risk of someone else getting access to the link and then trying to log into this this meeting. The second part comes on the resolution of this meeting domain, right? So how do you resolve the domain, right? So there is a DNS request, then there is an HTTP request, which is going to the application domain. Now, what happens? So in general, how it works out is that you send an HTTP, you try to visit the domain, browser sends a DNS resolution request, then it sends an HTTP request to the Google server. Now, what happens? The DNS server, which is in your region, is requesting a high throughput. Let's say millions of requests for the DNS resolution are coming into picture, and the DNS server is not able to resolve it. What will happen then? Your request will be either dropped or it will be put into a queue. Now, if it is put into queue, let's say if it is in a queue for 2 minutes, then for 2 minutes, you'll not be able to access this application. That is a 2-minute service disruption, right? So how does security come into picture? You implement different layers of DNS protection. You do DNS query over TLS, which is called DNS over HTTPS, which is a new concept. So there are different level of controls that you can apply there, right? But each step that you take for a functionality point of view, from a functional point of view, will also involve a step of security. It can be a control, or it can be a behavioral step, or it can be a change of way doing things, right? What makes cybersecurity career an interesting option, right? So have you ever had this feeling like wherein you were trying to search for something, or you were trying to find something and no one was able to find it, but you suddenly found it, right? So it gives you a unique feeling that no one was able to do it, but I can, right? So majority of the work in the cybersecurity space is almost similar, right? You try to find something that no one even knows is there. How? If a developer is developing an application, right, or if a network engineer is creating a network, they try to do their best. They try to create a network that is robust, that is solving all of their functional requirements, that is able to cater to all of their users, right? For application, you are writing a code which is secure, right? You try to make sure that all of the functions are available, users are able to do what you intend them to do. But when a cybersecurity professional comes into picture, right, they try to think out of the box. Okay, you have implemented this feature and you want the users to do it, right? But have you added sufficient layers of controls? So let's say you're sending a message to someone, and let's say on Facebook, right? So you add someone on friend, and then you can send them a message. But can you send them a message before adding them as a friend? No. By default on the features, you'll not be able to see a message option. For some users you can, but majority of the users you cannot see the message option, right? Now, what happens, how does the message process work, right? So when you open the chat window, it generates, there is always a user ID, a unique user ID. And when you send the message, a HTTP request is sent with the user ID along with it, right? Now, let's say if you go to one of your existing friends, you take that request as an example, and then you replace the user ID with someone who is not your friend. Will the application still allow you to send the message, or will it not? So that is something that a cybersecurity professional tries to think. So we try to think something out of the box that is not intended by the default behavior. So if you go to the web application, you're just browsing through, you'll not see that option. But if you try to do it forcefully, will it happen or not? That is the part of cybersecurity work. Now, if it happens, then that is an issue. If it doesn't, that is fine. Now, a lot of things will happen, a lot of things will not happen, but the task for cybersecurity professional is to identify each and every variation of it. Now, this is just one way of doing things, right? There can be hundreds of other ways of doing the exact same thing. Now, for a cybersecurity professional, we have to find all those 100 ways. And what does an attacker do? He only needs to find only one option. So let's say if they are able to identify just one variation of it, they'll be able to exploit it. But when you think of security, right, we have to find all of those 100 so that the attacker does not find a single option there to do something which is not intended. So that is what something makes the cybersecurity career really interesting. You're running on three different, running on three different wheels, right? One wheel is the developer, you have to guide them. Engineers, you have to guide them. You have to tell them what are the controls that they have to put in place, what are the different variations they have to take care of, right? You also have to look for something that even after you have provided them the guidance, they are still missing out on something. So you have to search for those things as well. Now, how do you search for something that you don't even know there is, right? So what you do is like you look at the request, you look at the behavior. How does the application react? What if you do something unexpected? Let's say you create a request and then drop it. Let's say you log into the application, take a URL, then log out from the application and try to visit the same URL again. Will the application still allow you to visit an authenticated path? Right? So there are different ways to do things and you have to think out of the box. And that is something which, for me at least, makes the cybersecurity career really interesting. You have to guide someone, you have to think out of the box, you have to find a lot of different variation that no one else will even think of doing. And then you have to find each and every of those variations so that the attacker does not find anything at all. So let me know if you have any questions, anyone, right? And also let me know if you think I'm going a bit fast or if anything is difficult to understand. Okay, so different paths in cybersecurity, right? So as I mentioned, even the ones that I have listed here are just a drop in the ocean, I would say. There are still a lot more careers, but I've tried to pick the most major ones, which cover a vast variety of the work. One is the network security. So you can think of it as network security work is majorly around your physical networks, your cloud networks, your router, firewalls, right? Your intrusion detection systems, intrusion prevention systems. You have uh, operations, analytics around the network, right? Performance monitoring, threat monitoring in the network. So all of these work related to network security comes there. Now, in the simplest term, you have, let's say you have the computer lab, right? So there are 3 labs. All 3 labs are interconnected with the LAN connection, and all the systems can interact to each other. You can ping the IP of a different system from the different lab, right? And then we have the, let's say, head of department lab, but you cannot ping that system. Why? There's a control layer between, right? So the switch does not allow you that. Or let's say there is a firewall which restricts you to connect to that, right? But that connection, right, that protection that you have put in place with the firewall, that is part of the network security work, right? So you have to put in those controls. Now, let's say someone goes into that lab, takes a computer and starts sending out network packets. Or let's say someone installs a malware. I hope everyone knows malware, right? Let's say someone installs a malware, or someone installs a worm and it is trying to replicate into different systems. So the network security part comes into picture, wherein they will intercept the network, they will review all the packets that are being transmitted in your network and try to analyze the patterns, that what is someone trying to do. Second, it will look for specific signatures. Let's say if you have installed a worm and it is being transferred in the network packets, it will look for the signatures of the worm and identify that this is a malicious packet, and then it will immediately trigger an alert. Then it will isolate that system. How do you isolate a system? Simplest way is you create a segregated network which is restricted with a firewall, and then put that system into that segmented network, right? You can also do another thing, right? Just drop that system from the, on a smaller scale, right? You can just drop the system from the network, or you can block the ports for the system, right? But for that, you need to have that level of privileges and controls on the system. But network security generally goes into that direction, right? Your firewall controls and your protection on the network layer and the packet analysis and all of that. Second is information security. Okay, so information security is, as the name suggests, so any information that is there, right? It can be your data, it can be the work that you are doing, it can be, let's say, you're visiting an application in your browser, right? So that is the information that you're traversing through, right? So anything that is your system, right? And let's say if you're working for a company and you're doing your regular work there, right? Now, let's say something happens on your laptop, right? So to prevent those type of things and make sure that such incident does not happen, that is part of the information security. And a vertical of information security is enterprise information security, which what they do is like they'll install softwares, controls, MDM solutions in your laptop, and they'll try to ensure that nothing malicious is happening on your system, right? So let's say for your work, you need to browse a lot of internet, but what if something malicious is downloaded, right? So you need to prevent that. You need to prevent your information which is there in the laptop. You need to prevent the information that is being transmitted out. So all of that is taken care by the information security. Second is cloud security. Third is cloud security. So cloud security, think of it simply as we used to have the physical systems, servers, DNS servers, right? Data centers and all of that. Now, majority of these things are migrated to the cloud environments, and majority of the cloud environment providers are AWS, GCP, and Azure. Now, all 3 providers, what they do is like they provide you a layer of integrity and a layer of security assurance. So what they do is like we provide you the hardware, we provide you the kernel layer, and now on top of that, there is an OS layer and the software layer, application layer, right? And you can even deploy your own services. Now, whatever you deploy on top of it is yours and you manage it. But the availability, integrity, and the security of the hardware that we are providing you, and you don't need to worry about it. Now, let's say if you're hosting an application and suddenly a lot of load is coming into picture, right? Let's say you are the owner of Meesho and you are on a physical network, right? You have physical data centers, and now you are trying to run a sale, and you're assuming that at least 10 times traffic will be there. Now, are you going to add 10 more servers in your data center just to manage that load? That is a tedious job to do, right? But if you're in the cloud, it's just a simple configuration. You just do the scale up configuration. And once you do the scale up configuration, as in the load increases, it will scale up your system. It will add in more EC2 instances. It will add in more servers, more databases if required, right? And when your traffic goes down, it will automatically scale down as well, right? So you don't need to worry about your infrastructure and all of that. But when you have all these facilities provided to you, right? So every facility comes at a risk. Now, the cloud provider, right? When they provide you the cloud environment, they isolate it into different accounts. So each account has its own dedicated isolated controls. Now, providers will manage that majority of the time. But the way you are doing things in your physical network is different from your cloud network, right? So that introduces a lot more risk, a lot more security controls that needs to be put in place. And all of that is taken care by cloud security. Application security. So security actually depends on the classification of data. What does classification of data mean? Let's say you just wrote a random paragraph, and that is again a data, right? And you uploaded it somewhere. Now, that is a data. You wrote the data, but that data does not have a significance. Why? It does not relate to anyone, and it does not contain anything sensitive or provide any sensitive information about someone, or it is not sensitive in itself, right? Now, second is, let's say a nuclear launch codes, right? Someone is just putting them in a text file and then uploading in a cloud provider. Now, that is sensitive, that is critical, tier 1 information. What is next? Next is, let's say you are creating a profile, any application, right? You have your profile. What does profile contain? Your name, your mobile number, your email address, right? And if it is Amazon or something, right, it will contain your payment information. It will contain your address. Now, all of that information becomes sensitive. Why? Because that information can identify an individual. And if it is leaked, that individual can be targeted. Targeted how? Almost everyone should be receiving like telemarketing calls or calls from someone that you have never even shared your information with, right? Again, different providers share the information between each other. There are clauses for that. But what data security takes care of is it ensures that your data is classified properly and the security controls are applied based on the classification. One example is if you're, let's say if you go to Amazon and you try to purchase something with your credit card. So Amazon stores your credit card information. How does it store it, right? So there are PCI DSS standards. They guide you how the PCI related. So PCI DSS is basically a standard for payments. So whenever you are dealing with payments or allowing someone to make payments with credit card, debit card, or bank or anything, right? So that involves a standard. It's a regulatory standard, PCI DSS, right? So it guides you how do you store that data, right? So they have defined an encryption algorithm. They have defined the security controls and the network controls that you need to put in place. The server which is holding this information, the database which will be storing this information, encryption on the database, encryption on the tables, encryption on the column, right? And then masking of the information, right? So in general, when you now one question that might come into some people's mind, right? That I'm saying that credit card information is always encrypted while storing, right? But still, if you go to profile, you'll still see sometimes the last 4 digits of your card number. Sometimes you'll see the expiry. Sometimes you'll see the PIN number, which is the first 8 digits, right? So while there are standards, there are also some applicabilities that are allowed, right? Some part of applications and functional things are allowed. Now, if you have the entire card number, right, you cannot show it. But if you encrypt everything and you do not show it to someone, how does a person identify whether it is my card or not? How does a person identify, let's say if a person has linked 10 different cards, how does he differentiate between different cards, right? So some data is still allowed to be used and displayed. And the classification goes in, you have a bin number, then you have 4 digits, which are never allowed to be shared with anyone. And then you have last 4 digits, which is your which are displayed in your profile, right? So bin number is generally it's not sensitive. Why? Because it identifies your bank and your specific branch. So the BIN number is generally your specific branch code. And the last 4 digits can be used to specify which card it is, right? So generally this information will be available, but what is not available? Your middle 4 and 6 digits and your CVV number, which is considered tier 1 sensitive information, and it will never be displayed or even stored in some cases. Now, compliance, right? So compliance is someone that's a part of cybersecurity vertical, which does a lot of documentation and regulatory work. So what it takes care of is that, let's say PCI says that you need to be compliant with us, and if you're handling with payments. Now, compliance is the department of cybersecurity which ensures that we are adhering to all the demands and the requirements that the regulators have put in place. Now, it's not just the PCI or something, right? Let's say if you want to do a business in India, so Indian government enforces certain boundaries and restrictions on every organization, that if you're dealing with Indian citizens' information, you have to adhere to these laws. If you're asking Indian citizens to do the payment, then you must have a requirement of OTP. Now, if you go outside India, right, majority of the online purchase platforms, they do not require a MFA or your OTP or something. But in India, it is mandated by Reserve Bank of India, right? Why? Because that is a government regulation by RBI, and the compliance team of any organization will have to adhere to that requirement. Otherwise, they'll not be able to do business in India. Now, many of you might have heard of GDPR, right? So GDPR is for European Union. So they have their own set of compliance requirements that people need to adhere to. How do you store the information of our users? How do you like access or even use that data? Which is part of the European Union people, right? So every country, every regulatory body has their own requirements, and compliance is the one, and the GRC, which generally take care of these part of things. Second is the last is cyber assurance. Okay, cyber assurance is kind of interesting because compliance comes into picture that you have to do this, right? Application security, network security will test it out whether it is working fine or not, right? But combining these two and making sure that everything is actually in place and we are compliant, right? That is the job of the cyber assurance. So they make sure that every system, every application is adhering to all the requirements. They are the one who continuously do the review of all the regulatory and compliance requirements and everything. Any questions on this?
Dear students, you may ask questions if you have any. It's fine. Open up your mic and ask him. You can talk to him directly also.
No, sir, you can carry on.
Okay. So next is exploring different career options, right? So these things that I talked about, right? These are different paths, just a limited number of them. Now, the specific role, right? So what is your specific role is going to be if you want to work in cybersecurity, and what will that role entail? What will be your the job description, let's say, in general, or what exactly you will be doing in that role, right? So there are security analysts. Now, analyst, whenever you hear the term analyst, right, the part of the work remains same, just the work that you're doing changes. So if you think of a data analyst, it will be dealing with the data, creating different compositions of the data, creating entities, relating the data, right? Now, a security analyst will be doing the exact same work, but for the security issues. So it will be looking for security issues by running tools. It will be analyzing them. It will be creating categorizations of them, then ensuring which categories are critical for your organization, what you need to work on, what should be the plan and the measures that you need to put in place, what should be the controls, right? So analyst generally does all of that work. Second is penetration tester. Now, this is a more hands-on job wherein you actually have to look for security issues and you need to try to exploit them. Anything that is not exploitable will not be considered an issue. So I gave this example of sending message to someone, right? So if you're able to send the message without adding friend, that is a security issue. Now, that is the role of pen tester to identify whether it is doable or not. Now, in the cybersecurity, there are 3 terminologies that are used very often. One is risk, second is threat, and third is exploitability. What is a risk, right? So risk is, in a general example, right? Let's say if you walk on the road, you can get hit by a car. That is a risk. right? Now, what is the threat? Threat is, okay, if you walk on the road, you can be hit by the car, but is there even a car there, right? And why would you be hit by the car? If a car is coming, you'll hear the noise and you can move away, right? A lot of things can happen. So that is just a risk. It can happen, right? But whether it will happen or not is a question. Threat. Threat is something which can lead to the risk, right? Let's say if you're wearing your headphones and then you're walking on the road. Now you wearing those headphones is a threat. Why? Because you're walking on the road and you're wearing your headphones, right? So threat is something which is relating you to that risk or exposing you to that risk. Now, third is exploitation. Now, exploitation is whether or not you can utilize that threat to reach that risk. So let's say you're wearing the headphones and you're walking on the road, but whatever it is, a side pathway, right? Which is, let's say, the walking trails. So everyone walks there, right? There will not be any cars in that trail, right? So if you're walking there, it is not exploitable. Why? No cars will be coming there. But if you're walking on the national highway with your headphones on, now that is an exploitable threat leading to a risk, which can be anything, right? So this is the concept of exploitation, threat, and risk. And this concept is mostly utilized by the pen tester because they have to exploit it. They have to understand the risk. They have to understand all the different threats that will come into play to reach that risk level. And they have to actually test it out and make sure it is happening, right? Security engineer. Security engineer has a kind of a reverse role compared to penetration tester. Now, pen tester is mostly attacking, right? But the security engineer comes into picture. He's on the defending side, right? They also attempt to exploit things, but they are also the ones who are dealing with it. So let's say pen tester says that there's this issue. Now, security engineer is the one who is going to validate it, understand it, why it is happening, how it is happening, what is there, what is wrong in the application code, or what is wrong in the network, and why it is exactly happening. Once they understand it, they'll reach out to the application developers, they'll reach out to the network engineers, they'll guide them on how to mitigate this thing, what controls they need to put into place, what should be the guidance, whatever the guidance they have to provide, right? They will need to provide all of that and then make sure it is actually mitigated. Next is security consultant. So consultant, as the name suggests, they consult, they look at your organization, they look at your architectures, they look at your applications, your networks, right? They try to identify different gaps and then they will consult you. Okay, you may not have an exact security issue here, but something may happen. Why? We are seeing that there is some lack of due diligence here. We are seeing, let's say, you don't have a firewall in this subnet, or let's say your application developers are not actually trained for mitigating certain type of vulnerabilities. You're not using certain best coding practices or something like that, right? So their job is to identify these type of gaps and then consult an organization or a team on how to mitigate those things, right? And what should be the best practices they are following, or what should be the methodologies they will be adapting to, right? So those type of things. And threat detection and incident response. This is an interesting role. So let's say someone is doing something malicious in the network, as per my previous example. The person who is supposed to detect it is the threat detection engineer. And once they detect it, they are going to do an incident response. What does incident response means? Okay, someone came into network and you blocked it, right? But before you identified it, what happened? How long the threat was there in the network? How long someone was exploiting the vulnerability in your application code? By exploiting it, what all did they do? Did they perform any action? Let's say someone is in your network and they were on your server and they created new accounts, right? Now you blocked that access, right? You detected it, you spotted the attacker, you blocked their access, but they already created a secondary access on the server which they can utilize later. How will you identify that, right? So that is the part of incident response. So once the detection is done, you have to do an incident response and you have to look at the trail of their logs, what all this person performed, where all this person went, what all actions they tried to perform successfully or failed, and then analyze all those behaviors and identify their tracks, and then look for any loopholes or any secondary vulnerabilities that they introduced in your system or in your application, right? And then you mitigate those, and then you create a report out of it, and then you present it to your leaders, right? And then you guide them that this happened, this person did all these three things, right? And we have mitigated it, but in the future, what if same thing happens again? What controls are you lacking right now? What let's say if it is a methodology, it is a best practice, or a software or hardware control that you're missing in your organization? What is it exactly that led to this attack happening? They discuss and debate about this, and then they identify a permanent solution. Okay, if we do this action, if we adopt to this methodology, then this same thing will not happen ever again, right? We have a certain level of assurance that it will not happen again. At least by the same method, it will not happen. Because within cybersecurity, you cannot say anything for 100% certainty, because there can be hundreds of different ways to do the exact same thing. Now, can you say for certain that you have identified all the possibilities? No. What you can say for certain is that we have a sufficient layer of control and a sufficient layer of detection. So majorly, we can identify a lot of things happening in the network, in the application. And for anything that is known right now, and even something top of it, we have a control or a mitigating layer in place, right? So you always have a control and mitigation layer in place, but you cannot say for certain whether something will happen or not. So you have to be always prepared. You have to be always on your toes and keep looking for something, right? Security architect. Most of you might have heard of like a software architect or solution architects and things like that, right? So security architect is also similar. Now this architect is going to design security. It's not going to design your application architecture or your servers, but it is going to design security for your organization, right? So how the different components are going to, so right now, all these people, right, they are working on different things. So this person works on just the analyst, this is just exploiting, this is just mitigating, this is just guiding. But the security architect comes into play. He will look at your entire organization on a holistic level. Okay, you have systems in your cloud servers, you have physical data centers, you have office locations, you have laptops given to the employees, you have email exchange servers, you have SaaS applications, then you have people visiting internet and downloading random stuff, right? So a lot of things are there, right? And this person will be designing security on a holistic level that, okay, on this level, you have to have these controls, and these controls will be tied together with these controls, then next controls and all, right? So to give an example, right, within an organization, there are, I'll talk about a few controls, right? So within an organization, you have, let's say I have my work laptop, and whenever I visit something over the internet, or if I try to access an application which is specific to my organization, right? So let's say if I try to visit that application, what happens? First, it will check whether the request is coming from the laptop, which is given by the organization. How does it check it? It has agents installed on the system which provide you that attributes, which are attached to your initial request, right? So with those attributes, it will identify that. Now that is a control, that access is coming from a given laptop. Second, do you have permission to access that application? How does that being taken care of? So there's a concept of identity and access management. The concept has two parts of it. One is, who are you? What is your identity? Who are you within this organization? Now, second is, do you have access? What is your authorization level, right? What is your access level? Now, if both match, you're allowed to access. Now, third part, what data you are accessing? Are you allowed to access that data? Now, is that data sensitive? Are you only allowed to view it, or are you allowed to download it as well? If you are downloading it, should it be downloaded in the clear text, or should it be masked, or should it be encrypted, right? So that is taken care by a layer called DLP, data layer protection. Then there is another layer called CASB, which is Cloud Access Service Broker. Then there is another layer called email security. Then there is another layer called Zero Trust. There are like different layers, right? But the role of security architect is to make sure all these different layers are considered and they work together. And he is the designer who will make sure all of these work together to ensure a holistic level of security for your entire organization. CISO, so he is like the boss of cybersecurity, and that is also the topmost position within cybersecurity. And he is the one who will be guiding and leading entire cybersecurity with a vision. Now, when you talk about cybersecurity, right, there are hundreds of threats, hundreds of risks, right, even thousands, right? And every other day there will be something new that everyone will be talking about in the market. Okay, a new attack came into picture, or this organization's data was breached, this organization had a ransomware attack, right? A lot of chaos will be created. But is that information related to your organization? Is that risk relevant to your organization? Is that something that you should be focusing on right now, right? So all of that is considered by the Chief Information Security Officer, which is the boss of cybersecurity. And this is like an aspiring role for almost anyone who is working in cybersecurity, even for me, I think 5 or 6 years later, I hope. And second is, next part is learning sources, right? So I've given you all this information around security roles, career paths, what security does, how it works and all, right? And to be honest, it might seem like if you want to get into security, right, you need to pay a lot, you need to purchase courses or like do trainings and all, right? Paid trainings mostly, or need to do some certification now. But if you want to get into cybersecurity, it's practically free. The only catch is you have to learn a lot by yourself, right? So I've listed some resources here. I'll share this presentation deck later on with sir, and they can share with all the students. And I will even add some more content to this later. I can share a lot more. For this presentation, I was not able to add a lot more information on the learning content, but I have a plethora of data of learning sources and a blog post, training sources, video tutorials, and all of that. So anyone interested can reach out and I can share all of that information with you. But to start into cybersecurity, you don't need to purchase anything. Majority of the information is freely available. There are hundreds of blog posts which are available. So I've given like just a few examples. I'm not sure whether it will be shared or not. Yeah, I think, yeah. So this is like one example that I've shared, right? So this is related to web application security. So if you just go to this application and sign up, majority of the content here is freely available, and it will guide you through from the basics about all the application security related issues, how they come into picture, how they are introduced in the application, what code is impacting or creating that type of issues, right? So SQL, GraphQL, prototype, SQL, XSS, CSRF, right? I'll not explain about each of the vulnerabilities right now, but you can go to these courses, right, and learn from there. And I have also posted some of the Twitter handles here. These are again like just a few, and these are some of the handles that I follow myself. So what they will do is like on Twitter, they will be sharing a lot of content, discussing about certain things. So even if you don't understand what they're talking about or what they are sharing, just reading through it will give you an understanding of a part of things, right? So try to follow these people, try to use, there'll be a lot of noise, right? Real noise, which will not be relevant or which will not be related to cybersecurity. But if you try to use the applications in a correct way, you'll find a lot more information which is relevant to you and will be beneficial to you. So you can try to follow these handles and learn the content which they are sharing. Another is edX. This is something that Ankit Panch sir shared with me when I was in college. And they also have a lot of, I would say 90% of the courses available here are free. You can go through the courses, you can do the trainings and everything. Just you don't have to purchase the certificate. If you purchase the certificate, they'll charge you something. But who needs a certificate, right? Majority of the thing is that you require learnings and you require the content, right, which is freely available. Coursera also has a lot of content. Cybrary is something specific to cybersecurity. And they have many paid courses, but there are some free courses available as well. And I can share a lot more contents, but these are some of the contents that I could add right now. And we'll have some issues.
Lokesh, yes, we can take some questions if anyone has some questions, because we only have like 4 minutes now.
Yes, sure.
Anyone wants to ask any question? Akhya, if you have any question, you can ask.
Yes, sir. There are a few questions that students have asked. So the first question is,
We have only 4 minutes, so keep it short. Like now it's 3 minutes only.
okay, sir.
I can take 5-10 minutes extra. That's fine.
No, actually, this free version
Okay.
of Google Meet
Okay.
only allows for 1 hour of meeting. That's why.
Is it okay if I share a link? But I have Zoom. Or I can
Like
share
what?
another link. I can share another link in the chat. We can join on that.
Okay, yes, we can do that.
Okay. Just give me a minute. I'll just share a link. I shared a link in the chat. Enjoy.
सभी लोग जो भी इस मीटिंग में पार्टिसिपेंट्स हैं, ये जो चैट में जो अभी आपके पास एक लिंक आया दूसरा, आप इस पे आइए, क्योंकि ये वाली जो मीटिंग है ये 1 घंटे में खत्म हो जाती है. इसका मैक्सिमम टाइम 1 घंटे है. तो आप सब लोग आइए, इस वाले जो चैट में जो लिंक शेयर किया उस पर क्लिक करके उस दूसरी मीटिंग में आ जाते हैं. वहां पर हम इसको और बातें कर लेंगे. आइए प्लीज, जल्दी आइए. Once again.
The link?
Yes, just paste it once again.
Okay. I can do both the chat. So I think by the time Akhya comes back on the call, what I can talk about is some security in the applications, right? So anyone from the application, from the computer science engineering who has some developing experience or any coding experience wants to chime in here. We can have a discussion. We can talk about how application is built and how security is embedded into each of these steps of that.
Hi, sir. I am not totally in a development field, but I am into web security field, in which I perform like a cybersecurity pen testing type of stuff in that. So my question is that I have an understanding about the web security vulnerabilities, but I am encountering the challenges in entering the field of bug bounty program. So how can you guide me that how can I overcome this barrier of getting entry in the bug bounty field?
Okay, so getting entry is really simple. You just need to go to HackerOne, BugCrowd, or some other platform. I'm sure you are aware of that. Just go to the platform, register there. Now, the challenging part is not so as soon as you register there, right, you're already entered the platform and you're already part of the bug bounty community, right? You can go to any program, you can report the issues there. The difficult part is reporting a vulnerability, of finding a vulnerability and then reporting it, right? So
Yes, sir.
sure, you are finding a challenge into finding vulnerability into those targets itself, right?
Yes, sir. That's the major difficult part that I have.
So, I have stopped doing bug bounty quite a few years ago, but from 2016 to 2020, I was doing it almost regularly, and all the recognition that I have, majority of them, and even the CVs that I have are from bug bounty. But so, how do you get in? How do you start looking into that, right? So, first challenge that comes to you is once you open a program available there, you see the scope that they have listed, right? And it will be a huge scope. Now, the vulnerabilities that you have in your mind, right? So let's say XSS or IDOR or SQL injection, right? So when you think of this vulnerability, it is pretty easy to visualize them in your mind, right? But when you look at the application, it becomes difficult that how you are actually going to attempt that and identify that. So one solution is that reduce your scope. So if you look at the entire scope, let's say facebook.com. Now within facebook.com, how many features are there? Hundreds. How many URL paths are there? How many APIs are there? Right? You'll not be able to count how many are there. And if you start looking for accesses in all of them, it will take you at least 1 year to even attempt. Right? Now, what you can do instead is go to a particular feature, restrict your entire information gathering, your entire enumeration and attack surface to just that one feature, and then take step by step, try to view that feature. So you'll see multiple API calls. Let's say if you're utilizing Burp Suite or some other platform or proxy tools, right, a Zap or something else. So when you view that feature, just restrict all of your requests to that feature, and you will get a multiple API request crawled into your, or your web request crawled into your Burp Suite. Now, take one request out of it, understand what that request is supposed to do. Now, let's say if it is a request which is just fetching information based on no parameters, right? Now, can you actually attempt SQLi there? No. Why? Because it is not taking any user input. Can you attempt XSS there? No, it is not taking any user input. So what is going to reflect there, right? So you have to think from the application's functionality point of view that what this API call or a web URL is trying to do, what data it is taking from you and how it is processing that, and based on that, how it is going to respond, right? So you have to analyze that behavior. Now, let's say, take example of message, right? So when you're writing the message, right, it is taking an input from you. So you can attempt XSS or something, or template injection or something else in the message. So if the message is not being passed properly, or it is not being, let's say, escaped properly, then your payload will reflect there and it will cause you, it will lead you to an XSS or something, right? So you have to take account of what the API is taking from the user input and how it is handling that. Based on that, your attack surface will be created and different vulnerabilities that you can attempt. So take one API, attempt all the different things that comes to your mind, analyze the behavior. If you see any oddity in that, any weird behavior, then you have to fuzz further. Try different payloads, try different input methods, right? Try to change the request method from get to post or post to get or something like that, right? So try out different things, but take it step by step. If you look at the entire picture of, let's say, entire Facebook, and you have, let's say, 1,000 API calls, and you start attempting once or twice on a single API for XSS, if you don't find anything, you'll move on to the next API, right? If you do that, then you'll not find anything. So take one feature, one API, attempt everything that you have on your mind, then move on to the next one. And majority of the issues that you will find will not be on a single API. majority of the issues that these platforms have now are related to behavior. So the behavior as in a logic. So application. So whenever an application creates a logic, it is not a single API logic. It is a multi API level logic. So even if you're doing a payment, it is at least 6 to 7 API calls which consolidate a single feature of payment, right? So let's say something happens on the first API, something happens on the second, then third. How all these three actions are combined together to form a single logic, right? So you have to understand and try to break that logic, and then you'll find a security issue. I hope that answers.
Yes, so that was really helpful for me. Actually, I am trying to get certified in a cybersecurity by preparing for the exam for CEH. That's why I am first of all I am trying to do pen testing with the Try-Acme platform. Approximate 50 plus labs I solved on that. Also, port swinger approximate 10 labs I solved, because that I'm thinking that. I don't need a total course material for CEH to qualify into that exam. That's why I'm preparing for that bug bounty thing, that polish my skills in that field. It is the right approach for me to
I
do
would
this.
say because a CEH, right, it's not just about bug bounty, and it is not just about the application security. CEH covers a lot more, right? So it's you can think of it as like an entry-level certificate, which covers all the different verticals that I've talked about, all the different parts of cybersecurity that I talked about, right? So CEH try to encompasses all these different parts. So you will see something around network security, you will see something around server exploitation, you'll even see something around Active Directory, you'll see some things around mobile security, you'll see things around cloud security, right? And there will even be some questions around incident response and data security. So that approach that you can do it just by bug bounty is wrong, because the course content is a lot more.
So how should I prefer to go for that?
Okay, so I have the ebooks. I can share that with you if you don't have the course content. So I can share the CEH ebook, but I have the V9 version that I had done long back. So I can share that with you. And from a certification point of view, right? If you do CEH, in practicality, it won't make much of a difference, because I had done the certification, and when I had done the interviews in 2016, no one cared whether I have CEH or not. And right now, like I do a lot of interviewing for my organization, and it doesn't matter whether someone has CEH, OSCP, even CISSP, right? What certificate does is it guarantees that you learned something, you gave a test, and then you passed, right? That is all certification tells you. But whether you have the experience or understanding to practically implement that knowledge, right? So take example of this. You have solved these 70, 80 labs that you talked about, right? In these labs, you solved a lot of security issues, identified the security issues, right? But when it comes to actually exploiting them or finding them in a real world application, your mind goes blank, right? You're not able to understand how to look for it, where to look for it, right? When you have an easy target, right, you are given a single application, or let's say a single feature, and you're aware that you have to look for accesses here, or you're aware that you have to look for SQLi. It becomes a lot more clearer. But when you are in the blind spot with an application, it becomes that more challenging, right? So what I would say is, if you want to do the certification, you can, right? But focus more towards understanding those challenges, right? And CEH gives you understanding of all the different paths. But when you're actually going to do the job, it will only be a single path. So first identify which path it is going to be, and then focus on that. CEH can be your entry certificate. Yeah.
Sorry to interrupt. I am going to more about the VAPT part of the security. And like I am not into SOC part, so that's why I am more focusing on that.
Okay, so CEH can be your entry-level certification, and for VAPT, majorly, so VAPT is again for network as well as for application. So make sure you are going for the application or network, whichever you are preferring.
Okay, sir. Thank you, sir. Thank you for help.
So there are a few more questions that have been asked by students.
Yes.
So the first question is, how one managed to get a job outside India?
Okay. Actually, depends on two things. One, whether you have that understanding. Let's say first, like simplest thing, right? You need to qualify for the job description which is given there. Second is your luck, whether they want to hire outside of India or not, outside their origin country. So let's say I'm working in Singapore, and when I moved here, I had offer from Ireland, London, and Singapore. Now, when you it depends on two things, right? One is you need to know where to search for the jobs. Second is you need to qualify for that job description. Third is you need to be on a level which is above what they can find in the origin country. So let's say if someone is hiring in Singapore. So first of all, government and everyone, right, they mandate it that you hire local. Now, if you're going to hire someone else, you need to justify that that person has the skills and the knowledge which you cannot find internally in the country, right? And then there are also some requirements which are like there are like a percentage restriction that how many people you can hire from certain countries, and countries outside India, they are trying to implement this right now. But I would say like go to LinkedIn, right? There is another application called Nodeflare and LinkedIn. I would say LinkedIn is more than enough. Go to LinkedIn, search for the specific category of the organization that you want to work in, and then the specific role, right? And then in the description, you'll see whether they are hiring outside the origin country or not, right? And then you try to apply. And if you're not getting any response on the LinkedIn directly, try to reach out, try to search for the application, right? The website of the organization, go there, directly apply on the main organization career page. Third is in the LinkedIn, you can majority of the time what will happen is that you'll see who the job poster is. It can be the hiring manager, it can be the HR. Try to add him or her as a connection, send them a personalized message on the LinkedIn, show your interest, right? And the next part comes in your resume. So the way CVs are written in India and how people expect it outside of India is a bit different, right? So you have to change your way of representation, how you are selling yourself in the resume, because that is the first part someone will look at and decide whether to give you a chance to towards the interview or not, right? So your resume has to be, if it is possible, keep it 1 page. If it is not, then max to max 2 pages, but don't create a 10-15 pages CV, right? And within those 2 pages, your focus is to tell them what you know, what you have done, what you have achieved, and what are your skill sets, right? And you have to explain, write it down precisely, but also in a way which shows that you have actually done it, right? So let's say I have recently done a POC for, there's a new technology called SASE and GTNA, which is a zero trust network. And I have done the entire implementation of that in my organization. So if I'm writing in my resume, I'll write down, led the implementation, implementation, budgeting, and resource management for SASE and GTNA project, right? Now it shows that you have done this. You have, what was your exact role in doing that? What all you contributed into, right? So that a way of representation will need to be there. Plus you have to keep it precise. And one more interesting thing that you can do is when you read through the job description, right, you'll see specific things that they desire out of this role. And some skills you will have, but might not be specifically mentioned in your existing resume, right? So always try to customize your resume for the specific job that you are applying for. I hope that answers.
Yes, sir. So I have one more question for you.
Yes.
How do you recommend handling incidents like data breaches or cyber attacks?
Whenever there is a data breach or a cyber incident, right? First thing is awareness, right? So all the different cybersecurity verticals which are related to it needs to be made aware that there is an incident. So in general, on an organization level, what we do is like we have a concept of a war room. So war room has 3 parts of it. One is a group email handle. Second is messaging. We have, let's say we use Slack or something. So there is a channel created immediately for that. And third is a Zoom call, let's say a Google Meet or a Zoom meeting. Now that remains active, all three, during the entire life cycle of the incident, and everyone involved will be available on them, right? Always jump into that. And then there is a document prepared for what is observed right now, what is happening, and all of that, right? So these are like the preliminaries or a prerequisite that you put in place. Now, you have observed a data breach. First thing is to identify what happened, right? A data breach happened, but what data it is, where is it, right? So you have to have that information, and the first responder will take care of that. They will identify all of that information. Second, why it happened. And a part of the second is mitigate it, control it, remediate it, right? So it works parallelly. So one team, which is the incident response, will be looking at why it happened, what all happened. They'll work, they will do the analysis of all the log trails, all the access, all the tasks that are performed, and how the data is being accessed, how whether it was downloaded or not. They'll try to look into all of that. Parallelly, the security engineers will look into why this issue which happened, this breach which happened, it is targeting to this database or it happened via this application. And these are the mitigating controls that needs to be put in place. Now, who is going to put them? How are we going to make sure that it is completely mitigated and all of that, right? So these two teams work parallelly. And all these steps that you're taking, every action that you're performing right now from the mitigation point of view, and every new information that incident response is discovering, all of them are documented, made aware to all the other people. Why? Because no single person will have entire context awareness of the system which is breached. So someone will have some part of information, someone will have some other part of information, right? So everyone comes together, shares their information, and then extends any extra information that they have. So let's say someone says that this database was breached or this server was breached, but another person might know that the server also has a whitelisted access to this different server, right? So it might be possible that this other server is also exploited, right? But by default, if you want to look at it, right, you'll have to analyze the logs and everything. So War Room helps out in that way, right? So you document all of that. Once your incident response part is done and your mitigation teams implements the initial control, then you start analyzing all the findings that you have there. What controls are put in place? Are they sufficient? What incident response found? Okay, this person breached the servers. He, let's say, tried to create an account but failed, but tried to download this data. Then they tried to do some lateral movement. Okay, they exploited a different server as well, which is with the whitelisted access. Now the security engineering will see the controls that we have put in place. Does it only mitigate the initial breach that we were made aware of, or does it also include or cover the mitigation for the new findings that are there? If not, they'll start working on that, right? Third is they'll try to identify a breach happened, but what was our SIEM doing? What was our threat intelligence and monitoring teams were doing? Why it was not identified early on? Why it led to a stage wherein the servers would be breached or the data was downloaded? So all that analysis is done. And once all of this analysis is done, it is converted into a report, and then everyone from the cybersecurity will sit together. They'll identify this is the entire problem statement. These are the controls we put into place. This happened. Okay. Now, what we need to do next? The next step is the disclosure of the breach. Now, if it is a breach which is relating to your, let's say, any personal information, right? I talked about the data classifications. If it is a personal information, or if it is a information which is governed by any regulatory body or the government, then you have to do a disclosure to the government body or to the regulatory authority, and then you have to give out a notification to all of the users, right? That is part of the process. So you have to make the users aware that something happened and it had this impact, and we have already put in these controls in place, and so far there is this impact, or let's say no user impacts were there, right? So all of that information you have to share. And same needs to be happened within the organization. Everyone needs to be made aware of what happened, and in future what all they need to do so that the similar thing doesn't happen again. That is the entire life cycle of an incident response.
Thank you, sir. As we have reached to the end of this session, I want to take a moment to extend my heartfelt gratitude to Mr. Lokesh Sharma, who has joined us today. The session was very intriguing and helpful. Once again, thank you everyone for being a part of this wonderful session.
Thank you, everyone.